Okay, so you might have also seen that we in the last lecture we did this energy available for the particle creation in lab frame and in the center of mass frame. What will be the center of mass energy available for the creation of the particles in the lab frame, and where we see that it varies as under root of E, and the energy available for the creation of the particles in the center of mass, where it is proportional twice E, right? So now sometimes we have, when the particle, we make some collisions, we need to find out the transformation equations of those energy momentum from one frame to the another frames. How we find out the transformation, later on we will do some exercise on it also, but the general method by which, by how we actually go from one frame, for example lab frame, to the center of mass frame, or from center of mass frame to the lab frame, how the transformation, how the measurements of energy momentum, and also the angle of emission of the particles that are being produced, they are actually related from two different frames of reference. So I will just start with again the same thing, same story, where we start with, I will consider two inertial frames of reference. Like for example, if this is a frame S, which is at rest, right? If this is X, this is Y, this is Z, and then I consider another frame of reference, which is moving with a velocity some V. This is Y dash, this is X dash, and this is here some Z dash, right? And this frame is moving with a velocity V with respect to, this is S frame and this is S frame, with respect to the frame S. So again, consider two inertial frames of reference, S and S dash. The frame S dash is moving with a speed or with a velocity V relative to S, right? Now, also we have obtained one relation, that is what we call as a force momentum. So the force momentum in can be written as, in matrix form, as, जैसे हम फोर वेक्टर कहते हैं, इसी तरह से हम फोर मोमेंटम भी लिख सकते हैं. That is P mu dash is some summation mu running from 1 to 4 a mu nu P nu. This is how we write down the four momentum in the matrix form. Matrix form में क्यों इसको बोलते हैं? Because this a mu nu, where this a mu nu is a matrix of the form like, I will call this elements like 1 1 1 2 1 4. So they have the, where mu is running from 1 to 4 and nu is running from 1 to 4. So I will have the elements like alpha 1 1. This is alpha. I will call this as alpha. A mu. Alpha 1 2. Alpha 1 3. Alpha 1 4. Alpha 1 4. Similarly, the second row elements will be alpha 2 1. Alpha 2 2. Alpha 2 3. Alpha 2 4. The third row elements will be alpha 3 1, alpha 3 2, alpha 3 3, alpha 3 4, right? And then the last row, it will be alpha 4 1, alpha 4 2, alpha 4 3, and alpha 4 4. Where these elements, we will see that what will be these elements. So these elements are nothing. This A11, A22, what are these elements actually? They are like, we have the metric tensor, जैसे हम लेते थे. So this is like this, the first element is gamma, this is 0, this is 0. This element here is I beta gamma. Now this is 0, this is 1, this is 0, this is 0, this is 0, this is 0, this is 1, this is 0. And here it will be minus I beta gamma, 0, 0, and gamma. So these are elements like this. So now you can correlate from this matrix that alpha 1 1 is equal to alpha 4 4 is equal to gamma. Alpha 1 4 is equal to alpha 4 1 is equal to I beta gamma and minus I beta gamma. Alpha 2 2, alpha 3 3, they are equal to 1, and rest of the elements are 0. Now based on these elements, now what could be this P nu? P nu will be like P1 P2 P3. ये P nu जो आपका होगा, it is be one column matrix, that is P1 P2 P3 and P4, right? What will be this matrix now? P mu dash will be equal to P1 dash, P2 dash, P3 dash, P4 dash, isn't it? So based on these, so I can just write it into the matrix form then. So So I will write down this equation in a matrix form like, so I will say that this P1 dash will be equal to alpha 1 P1. Once you will multiply here, look at this equation. Once you multiply these elements to P new, so we need to multiply. So P1 alpha 1, P2 alpha 1 2, P3 alpha 1 3, P4 alpha 1 4. इसी तरह से P2 dash फिर मैं इसके साथ multiply करूंगा, right? Okay, so what will be the second element? Second element will be now plus alpha 1 2 P2 plus alpha 1 3 P3 plus alpha 1 4 P4, right? And this will be alpha 2 1 P1, ये capital है आपका, alpha P1. What is this? This is P2 dash. P2 dash will be alpha 2 1 P1 plus alpha 2 2 P2 plus alpha 3 3. Oh, sorry, 2 3 P3 plus alpha 2 4 P4. Similarly, then you will write down the P3 dash and P4 dash. ये खुद से आप लिख लीजिएगा उसी हिसाब से. I will write down the final expression, right? Now what will be this equation? Then P1 P1. What is alpha 1 1? It will be gamma P1. Okay, yes, I will write it separately there. Okay. Now also we have obtained. So let me write this alpha 3 1 P1 plus alpha 3 2 P2 plus alpha 3 3 P3 plus alpha 3 4 P4. Then this will be alpha 4 1 P1 plus alpha 4 2 P2 plus alpha 4 3 P3 plus alpha 4 4 P4. Is it okay? कोई अपना एक स्पीकर आप ये अपना इस पे रखो, ऑन पे रखो. I want to listen from you also. 2-3 लोग जरा ऑन रखो अपना. So then, okay. Now also we know that this what we call as a 4 vector momentum. How we write down the 4 vector momentum? 4 vector momentum that is given by some P I E. IE by C भी लेते हैं हम, or sometimes we always write it as IE. What is this moment? This is the 3 vector momentum. So it will be like P1, P2, P3, and this energy is nothing, it is IE energy. This is a 4 vector momentum, right? This is a 3 vector momentum plus the energy momentum that makes us the, जैसे हम 4 vector में space of time लेते हैं, we call that as space time 4 vector. इसी तरह से energy momentum 4 vector. 3 components of the momentum and 1 component of the energy, that is what we call as a 4 vector momentum. That is what we call momentum. As momentum. Now based on these, what will be these equations? So what will be P1 dash? Now P1 dash will now become alpha 1 1 क्या है आपका previous slide पे, that is alpha 1 1 is gamma, right? So gamma P1 plus alpha 1 2 is 0, so this will make it 0 0, so this will be 0 plus 0 plus, okay, alpha 1 4 is beta, I beta gamma P4, isn't it? Similarly, what will be P2 dash? P2 dash will be now equal to alpha 2 1 is now 0 plus this is 1 into P2
minus iota
plus 0 plus this will be 0. क्या चीज?
minus iota beta gamma P4
minus
iota beta gamma
plus.
This is plus.
Plus.
This is plus.
जी.
This is iota beta gamma, not minus. Okay. Similarly, P3 alpha 3 1 is 0, so it will make it 0. ये भी आपका 0 हो जाएगा. ये आपका P3 हो जाएगा. Plus ये भी आपका 0 हो जाएगा. Now P4 dash will be now equal to Shabai. This alpha 4 4. It is minus I beta.
Minus.
This one is minus I beta gamma P1 plus second element will be 0. It will be 0 plus this will be gamma P4.
Gamma
P4.
4.
Right? Now I can write down this equation as, I will write down these 2 elements. I will write down this as gamma आपका common है इसमें. So I will write down equation as gamma P1 plus beta P4. I beta P4. I beta P4. Now this is P2 dash will simply be equal to P2. P3 dash will simply be equal to P3. and P4 dash, this will be equal to, यहाँ पे भी मैं गामा आपका कॉमन ले लेता हूँ. I will write down this as gamma P4 minus I beta P1.
beta P1.
Beta P1. Is it okay? उतना से ठीक?
Yes, sir.
See, or I can write down this equation as जो P1 dash है. What are P1, P2, P3? These are the coordinates. This is Px, Py, Pz, P4 is the energy component. So I will write down this equation as, so this is nothing. This is like P1 dash. This is P2 dash. This is P3 dash. This is P4 dash. Isn't it? I will rewrite these equations. See how I will rewrite these equations. I will write these equations here. So I will write down this as P1 dash is equal to Px dash. I will assume that 1 is equal to x. So P1 dash is equal to Px dash. Yani it is along the x-axis, momentum along the x-axis. So what will this equation now become? It will be gamma Px minus, oh sorry, plus Shabai,
Iota beta.
I beta P4. What is P4? What is P4?
Time.
P4 is my IE. P4 is my IE. So let me write it down. IE. P4 IE. इस तरह से. ठीक है? First equation. Now second equation P2 dash will be equal to Py dash will be equal to Py. Right? Third P3 dash will be equal to Pz dash will be equal to Pz. And the fourth equation now, that is P4 dash. So that will be P4 क्या है? IE. Let me write down these first three equations, then I will write down this. Now see, so what will be P1 dash P? This Px dash. Px dash आपका क्या हो जाएगा? यहाँ देखो, it will be gamma Px minus I beta IE.
Gamma.
That is gamma. Very good. This is Px minus iota into iota is minus beta E.
Minus beta E.
Very good. Beta E. So second जो है, this is Px dash. I will write down Px dash is equal to this. Py dash will be equal to Py. Pz dash will be equal to Pz. ठीक है? These three. Now coming back to the fourth equation, that is P4 dash. Now P4 dash आपका क्या है? P4 dash is IE dash. P4 is IE. So P4 dash का मतलब है IE dash. So IE dash will be equal to, from this equation it will be gamma P4. P4 क्या है आपका?
IE.
Very good. That's IE minus
I beta Px.
I beta
beta P.
Px. Very good. I beta Px. So again I will do one thing. Iota is common. I will take this as iota gamma E minus beta Px. Px. This is iota E dash. Now this iota and iota will again cancel out, and I will have, आप order में लिख लीजिएगा, मैं थोड़ा सा यहाँ स्पेस कम पड़ रहा है, आप पेज पे जैसे हैं. These are जो भी मैं स्टेप लिख रहा हूँ वो following steps होते हैं. So it implies this E dash will now be equal to I, not I. This is gamma E minus beta
E minus beta Px.
Beta Px. Right? So these are actually the transformation equations for the measurement of energy when we go from. So I will just write down these conversion equations, summarize. So conversion equations of what? Conversion equations of energy momentum in the lab, and उसको पूरा लिख लीजिएगा. Conversion equations. So the conversion equations for energy momentum. Energy and momentum from lab frame to the center of mass system is like, for example, the first equation is Px dash. Px dash is gamma Px minus beta E. जो हमने अभी equation first है. Py dash is nothing. Py dash is simply Py. Pz dash is nothing. Pz. And P4 dash, that is P4 dash means E dash. E dash is equal to gamma E minus beta Px. Now, if you look at these two equations and compare it with the equations जहाँ पे space time 4 vector हैं, they are very much similar to those equations. But वहाँ पे हम space और time का ले लेते हैं, यहाँ पे हम energy और energy का. Now you need to know, since we are now dealing with the frames of the references. Now, since we are dealing with the frames of the references, so remember here that this Px dash जो होगा, Px dash, this is just the momentum. ये लिख के रख लीजिएगा. Momentum along x-axis of secondary particles in center of mass frame, right? Now similarly, what is px then? Px is nothing, it is the momentum along x-axis of secondary particles in lab frame. Similarly, E dash क्या है आपका? E dash is total energy of secondary particles in center of mass system, या center of mass. And E is a total energy of the particles, secondary particles produced in lab frame, या rest frame. Right? So these are the conversion equations जो हम कहते हैं energy. Similarly, जिस तरह से हमारे पास space time coordinate में हमारे पास inverse Lorentz transformation या inverse transformation है, we can have the inverse transformations here also. So those inverse transformations are nothing. We can just simply obtain those transformation equations from these equations. Similarly, we can have the inverse transformation. So the inverse transformation can be obtained by replacing beta equal to minus beta. Beta क्या है? This is nothing. Beta is your v by c. ये velocity है v by c. ठीक है? v by c. So replacing जैसे हम वहाँ पे v to minus v करते हैं. So then what will be the conversion equation? Simply then px will now be equal to shabash gamma px dash plus beta e dash. Right? Beta e dash. Py will be equal to py dash. Pz will be equal to pz dash. And finally, E will be equal to gamma, shabash, E dash
plus beta px.
beta px. Isn't it?
Yes, sir.
है ना? So since you have done so many, a lot of exercise on it, so it's like actually as per that. That's the reason I started from that very basic thing. Otherwise आप लोगों ने वो सारी चीजें पढ़ी होती हैं, because मैंने सोचा आपका revision हो जाएगा and it will make me easy to make you understand this thing. Otherwise we were supposed to start it from the last lecture जो हम last lecture start किया था. Now initially मैंने एक और चीज इसमें लिखा था, energy, this is energy, this is momentum, and एक और चीज मैंने लिखा था, that is what is called as an angle of emission. So how the angle of emission, how we find out the transformation equation, how the angle, if I am finding some angle of emission of a particle in the lab frame, how will be it related to the measurement of that angle of emission in the center of mass frame and vice versa. Now since you know that tan theta dash, tan in center of mass system, tan theta dash will be given by tan theta, you know, that is always given by perpendicular by base. So perpendicular क्या होगा? So I will write down this as p perpendicular dash divided by p parallel. Base is parallel, p parallel dash. P perpendicular is nothing. For example, some particle is moving in this direction, so this is moving in the x direction, so perpendicular to this will be equal to y. So p perpendicular is nothing, it is p y dash divided by p parallel, that is x dash. So it will be simply px dash. समझ आइए? This is perpendicular to the direction of the motion of a particle. Now py dash, I can write this py dash as p sine of theta along the vertical component, and this px dash हमने अभी find किया है. Px dash is nothing, it is gamma shabash px dash minus beta e, right? So then I can find out the theta. This theta is the angle measured in the slab frame. Theta dash is the angle measured in the center of mass frame. So theta dash is nothing. Theta dash is just tan inverse. You will see जब हम इस पे exercise करेंगे, हम ये सारी चीजें find करेंगे. Angle भी हम, because उसमें हमारे पास angle of emission भी दिया होगा, and we will apply these simple formulas to obtain. So इसके जितने भी ये हैं, like for example this, remember this equation because we are going to use it later on. So it will be nothing. It is tan inverse p sine of theta divided by gamma px dash minus beta e, right? ठीक है? While this p क्या है? This p is nothing, it is the momentum of the secondary particles in lab. This is the secondary particles in the lab. Okay. Now let me just again quickly remind you some things again, जो कि हम already कर चुके हैं. थोड़ा सा मैं इस पे फिर से वो रिलेशंस आपको रिवाइज करूंगा। हमने लास्ट यूनिट ये लास्ट लेक्चर में भी किया था। तो द 4 वेक्टर मोमेंटम, 4 वेक्टर मोमेंटम, इज इट विजिबल? बोर्ड पे आपको दिख रहा है?
Yes,
Yes, sir.
Now 4 वेक्टर मोमेंटम जो मैंने जैसे अभी दिखा था, दैट इज मोमेंटम P एंड IE by C भी हम समटाइम्स देते हैं, IE by C ही लिखूंगा मैं, ठीक है। दिस इज 4 वेक्टर, so this is nothing, this is जो मैंने अभी कहा था, this is P1 P2 P3 and IE, fourth component is the energy component. Now you all also know that जो this P square minus E square, momentum square minus energy square, is always equal to P dash square minus E dash square. It is invariant. This is because this is equal to some rest mass, so this is always constant. ये हमने last time अगर आपको याद होगा equation में किया था, याद है ना? So we need to find out as what will be this P dash square. We will find out what is this equal to from the earlier equation जो मैंने, what is P dash minus E dash, P dash square minus E dash square हम देखेंगे किसके बराबर, ठीक है। तो we can just directly use this relation जो मैंने अभी find की है, like for example since you know that Px dash किसके बराबर है, this is gamma Px minus beta E, right? And E dash is nothing, E dash is gamma E minus beta Px, ठीक है। Now remember here in this case I will see that Px is equal to 0. Px is equal to 0. Why? Px is equal to 0 in S frame, the frame which is at rest. Why? Because it is at rest. Since it is at rest, so obviously the momentum will be equal to 0. Then what will be this E dash? Then E dash क्या होगा इसमें lab frame में? Then E dash will nothing. It will be equal to, when it is 0, it will be gamma E. Gamma E. Okay. Now E आपको पता है relativistic energy E is equal to this m0 c square. M0 total energy is m0 c square, है ना? Total अगर कोई particle rest पे है, the total energy of that particular particle will be the rest mass energy. So that's why E is equal to m0 square. So if E is equal to m0, it implies that this E dash will now be equal to, or I can say simply C0 में equal to 1 करूँगा, I will say that this is equal to m0. So E dash is nothing, E dash is gamma m0. Gamma m0. That is E dash is equal to gamma is, or I can also write this as gamma m0, right? Okay. Then what is Px dash? By applying this Px equal to 0 from this, and Px dash
Beta
will now be
gamma.
equal to beta Shabash,
Gamma beta.
मगर minus gamma beta E, minus gamma beta E, isn't it? Minus gamma beta, because Px यहाँ पे लिख दीजिएगा, because Px is equal to 0. Px is equal to 0. So what will be the Px dash square? Px dash square किसके बराबर हो जाएगा? It will be gamma square beta square E square. When squaring on both sides कर रहा हूँ, gamma square beta square E square. So now then what will be this जो मुझे find करना है? Px dash square minus Ex dash square. So Px dash square minus this thing जो मैंने कहा था E dash square, it will be equal to what is this Px dash square? It is gamma square beta square E square minus E dash square क्या मिला मुझे? Gamma. Okay, I will write down this gamma E, gamma because E में यहाँ पे use करा, I will write down this gamma square E square. समझ रहे हो बात को? और gamma square E square is common, so I will take this as gamma square E square में इसमें बाहर ले लेता हूँ, यहाँ पे आपका बच जाता है beta square minus 1. Beta square minus 1. But you know that what is gamma? Gamma is 1 divided by under root of 1 minus beta square. V square by C square is beta. So gamma square is 1 divided by 1 minus beta square. है ना? So gamma square is 1 divided by 1 minus beta square into E square into beta square minus 1. Beta square. 1. तो यहाँ पे मैं इसको एक चीज कर सकता हूँ, मैं 1 यहाँ से कॉमन ले लूंगा, सो इट विल बी सिंपली माइनस ई स्क्वायर. इवन ये तो ये कैंसिल, इट विल बी माइनस ई स्क्वायर. इट विल बी माइनस ई स्क्वायर, राइट. माइनस ई स्क्वायर आपका क्या है, ई स्क्वायर क्या मिला मुझे यहाँ पे, ई इज इक्वल टू m0. सो दिस इज नथिंग, दिस इज माइनस m0 स्क्वायर. m0 square. So I can say that this px dash square minus px dash square minus e dash square is nothing, it is minus m0 square, because m0 is the rest mass, it is constant, it is invariant, so I will say that this will always remain invariant. समझ लो बात को. Similarly, अब आप क्या चीज फाइंड करोगे, now you will find out, ये मैंने यहाँ पे किया है, you just find out px square minus e square. You find out this from all these relations. ठीक है? But now you cannot make px equal to 0, right? Because we are doing it in the lab frame. So px is not equal to 0. So what you need to do, you just expand all these terms. You just expand. आप px का वैल्यू सब्स्टिट्यूट करिए, px का क्या आ जाएगा, यहाँ पे इनवर्स आ जाएगा ना. px के बदले ये देखो आप क्या करोगे, देखो आप क्या करोगे, px is gamma
minus beta e dash.
very good. Or you can see that since it is square, you will say that this is gamma square, px dash plus beta e dash whole square, go px square minus gamma square into okay, plus e dash plus beta px dash mx square. ठीक है. अब इनको जरा मल्टीप्लाई कर, इसको पहले स्क्वायरिंग ये खोल लेना, उसके बाद मल्टीप्लाई करना, कुछ टर्म्स उसमें कैंसिल हो जाएंगी, एंड यू विल फाइंड आउट दैट दिस विल ऑलवेज बी इक्वल टू माइनस m0 स्क्वायर. ये आप उस तरह से करिएगा, ठीक है. यू जस्ट break the square term, add up the terms, and you will get this equal to m0 square. Is it okay? करोगे?
Yes, sir.
Very good. Now then quickly I will tell you one more thing that will be also helpful to obtain all these things. Once we will do some exercise in the next part, you will see how this will be very important. That is determination of this beta and gamma. How we determine this beta and gamma, right? See how we actually determine this beta and gamma. You know that in center of mass frame, the total momentum, जो मैंने परसों definition में बताया था, the sum of momentum of all the particles is equal to 0. So you will see that summation over I pi is equal to 0, right? Now if I am considering, for example, two particles, so or I can see for the two particles, you will see that this p1 dash plus p2 dash is equal to 0, right? P1 dash is equal to P1 plus P2. For example, some particles moving in this direction, some center of mass frame में ये होता है. If this is moment of P1, this is P2. P1 plus P2 will always be equal to 0. Or I can say summation of this P1, that is Pi, is always equal to 0, right? Now I will take the motion along the x-axis. For example, this is in some coordinate system. I am considering that let these particles are moving along the x-axis. Take motion along x-axis. Okay. So then I will consider this P1 and P2 as P1x dash plus P2x dash. Okay. While x simply represents that they are along the x and y direction. Now why I use this P1 and P2x dash? Because I already have obtained the equations for this. What is P1x, by the way? P1x किसके बराबर है? अभी जो P1x dash rather. That is nothing, that will be gamma. शाबाश. P1x plus minus beta E1 मैं ले लेता हूँ. Beta E1. Okay. And what is P2x? So plus gamma, this will be P2x minus beta E2. So this will be equal to 0. ये equation को मैं वही transformation equation कर रहा हूँ. Now you know that gamma can, since gamma is not equal to 0, because you know that the particles are moving certain velocity, and you will have this gamma as 1 by root of 1 minus beta square, that is some value. Since gamma is not equal to 0, then what does it mean? That means these two quantities, the sum of these two quantities will be equal to 0. So since gamma is not 0, therefore this P1x plus, sorry, minus beta E plus या minus beta E1 है ये, हाँ, E2 plus beta minus beta क्विकली मैं चाह रहा था कि ये जल्दी से फिनिश हो जाए so that आपको इनकी जरूरत नहीं पड़ेगी. Fine. I have some 5 minutes. जल्दी करो बस हो गए मुझे ज़्यादा कुछ नहीं बोलना है इसमें. Okay, so now this is gamma is not equal to 0, so then I will say that this P1x minus beta E1 plus P2x minus beta E2 will be equal to 0. Or I can further simplify. I will write down this as P1x plus P2x minus beta into E1 plus E2 is equal to 0. Is equal to 0. Now you can solve it for beta, or you can say that this beta is nothing. It is P1x plus P2x divided by E1 plus E2. E1 plus E2. Now you are you getting what is E1, what is E2? So see what is E1, E2. So for example, I have a target at rest. If this is a target which is at rest, the total energy of this particle will be equal to E2. Momentum will be equal to 0, and I have some particle that is coming in this direction. It has some energy E, total energy, and the momentum has P1x, right? So E2 will be equal to the kinetic energy plus rest mass energy. Now kinetic energy is 0 because it is at rest. So its total energy, this E2 is nothing. It will be just the target mass, MT, target mass. So based on this, agar E1 जो है, this is E1. E1 क्या है? E1 is the incident energy of the particle. So I will represent this E1 by E incident. So E1 I will call this as a E incident, yani energy of the incident particle, instant energy of the particle. So then how will I write down this beta as? Now then beta will be equal to Shabash. Now P2x is equal to 0 because the particle is at rest. P2 is so it will be simply P1x divided by E1. E1 क्या है? E1 is E incident energy plus E2 क्या है? E2 is nothing. It is the target mass. So this is the expression for the beta. Now there is one more case. If the incident energy जो होगी, if the incident energy is very large, yani is E incident is very much greater than the target mass. That suppose ये 100 GeV है और ये आपका mass of particle proton है मेरे पास, so that has an 1 GeV mass. So 100 GeV is very much larger in comparison to. So then I can replace this beta simply as P incident divided by I incident. P incident divided by I incident. यहाँ पे भी P incident ही करें, incident of momentum. So beta is nothing. It is P incident divided by I incident. ठीक है. Now once you obtain the beta, जब आपको beta मिल जाएगा, you can find out the gamma. कैसे? Gamma is 1 by under root of 1 minus beta square. So you can see that gamma is equal to 1 divided by under root of 1 minus P incident divided by E incident का square. P incident divided by E incident का square. So this is all about this the transformation equation of energy and momentum for the particles that are being produced in the lab frame and the center mass frame. Now for example, अब आज तो नहीं because I have some other assignments here in the department. So maybe I will take the class tomorrow evening. maybe मैं class लूँगा because मैंने कहा ना कि we need to finish some around some 50% syllabus by the end of before the end of this month. So now for example, I will give you a problem. The problem will be like you just give it a try. देख लीजिएगा by applying all these formulas जो मैंने यहाँ पे लिखी हैं. आप थोड़ा सा इसको try कीजिएगा. तो इशरत आप मुझे जरा फिर भेज दीजिएगा कि absent some 18 students are absent present. आप मुझे बता देना कौन absent था. So see the problem is like I have a 300 GeV proton. It collides with a proton and it produces a particle pi and some other extra particle. ठीक है. So the kinetic energy of the incident and the angle of emission of the pion, जो kinetic energy of incident pion होगी, proton होगी, kinetic energy is equal to 250 MeV. आप ट्राई कर लेना, अगर नहीं हुआ मैं कल बता दूंगा फिर. And the angle of emission is 5 degree. ठीक है, बट ये कहाँ पे है? This is in lab frame. बोलो, this is in the lab frame. So I have to find out. So what you need to find? This is the input. मतलब एक प्रोटॉन आपका कोलाइड कर रहा है और इस प्रोटॉन की जो टोटल एनर्जी है दैट इज 300 GeV. टोटल एनर्जी E 300 GeV. It collides with a proton with collides head on with a proton at rest. यानी एक प्रोटॉन आपका रेस्ट है, इस तरह से है कि एक प्रोटॉन आपका यहाँ पे आ रहा है और ये वाला जो रेस्ट है, दिस इज प्रोटॉन, दिस इज प्रोटॉन. इसकी एनर्जी जो है 300 GeV है और ऑब्वियसली सिंस इट्स एनर्जी विल बी 1 GeV अप्रोक्सीमेटली, है अराउंड सम 1 GeV. और इसकी काइनेटिक एनर्जी भी दी है. काइनेटिक एनर्जी इज 250 MeV और एंगल ऑफ एमिशन जो है द पार्टिकल्स प्रोड्यूस दैट इज 5%. नाउ वी नीड टू फाइंड E dash total energy, E dash momentum P dash and theta dash in of pion in center of mass frame.
Center of mass.
Like what? आप जरा ये इक्वेशंस देख लेना कौन सी मैंने इक्वेशंस आपने यूज किए हैं. Then if you got the answer that will be good. If somebody is not able to, but give it a try. अगर किसी का नहीं